So a digital fruit fly just woke up inside a computer and started walking.
Which is, yeah, it's just as wild as it sounds.
It really is.
Yeah.
And, I want you to really picture this, because I am not talking about, like, a video game character here or some pre-programmed animation.
Right.
I mean, a biologically accurate, neuron-by-neuron digital replica of a living organism. It literally woke up in this virtual environment. It seemed to process its surroundings. It groomed its antenna just like a real fly would, and then it just started walking around.
Yeah.
And the kicker here, nobody coded it to do that. It just did it.
It's one of those scientific milestones that, it really feels like science fiction is just bleeding into our everyday reality. And it forces us to ask some very uncomfortable questions about what life actually is.
It totally does. And hey, welcome to the deep dive. Today, we are unpacking a massive stack of sources to try and answer those exact questions with you.
We have a lot of ground to cover.
We really do. Our mission today is to figure out why this mind-blowing breakthrough in, uploading a fruit fly brain actually proves that human digital immortality is, well, it's a dangerous illusion.
A total trap, really.
Right. And then we're going to look at why this decentralized technology called Holochain might actually be our best shot at saving our digital agency from corporate control. Because as you'll see, before you start packing your bags for a digital afterlife in the cloud, you really need to understand the terrifying philosophical and biological catch that comes with mind uploading.
Yeah, because the achievement with the fruit fly is genuinely staggering. But because it looks so much like a successful mind upload, it's led a lot of people to jump to some deeply flawed conclusions about human consciousness and, what it actually means to digitize a brain.
So we have to start by getting grip on the science of how this actually happened so you can understand the sheer scale of the achievement before we kind of dismantle the myth of uploading. Let's go back to October 2024.
The Flywire project.
Yes, the Flywire project. They published this massive research paper in the journal Nature. They managed to map the entire brain of an adult female fruit fly.
Which took 10 years, by the way.
10 years. They used these electron microscopes to slice this tiny microscopic brain into 7,000 razor-thin images. And then they had this huge army of scientists and crowdsourced volunteers meticulously proofreading the data to map every single connection.
And what they ultimately built is known as a connectome.
Right.
Think of a connectome as the ultimate definitive wiring diagram of a brain. We are talking about mapping 139,255 individual neurons and over 50 million synapses.
It's just an unfathomable amount of data.
It really is. And they didn't just map the neurons, they mapped the projectome, which is basically the routing system. It showed them exactly how different regions of the brain communicate. It revealed these highly connected, rich clubs of neurons that act almost like broadcasting towers, sending signals globally across the fly's brain.
I like to think of it like taking a massive city's power grid, right, and mapping every single underground cable, every substation, all the way down to the last light switch in the smallest apartment. It is just a masterpiece of anatomy. But here is where it goes from a static map to something that sounds like actual magic.
Right, the simulation phase.
Exactly. Fast forward to 2026, a company called Eon Systems took this static wiring diagram and brought it to life. They fed the connectome into a digital simulation.
And this is where the specific software they used becomes really crucial in understanding what actually happened. They used MuJoCo.
Wait, MuJoCo? What's that?
Oh, it's an advanced physics engine. It handles gravity, joints, friction, all that stuff for the simulated fly body.
Okay, got it.
And then they used Brian 2, which is a highly specialized software designed to simulate biological neural networks.
Right, so you have the physics engine handling the physical body and the neural engine handling the brain map. And they used machine learning to predict which neurotransmitters would be firing at which junctions. They turned the simulation on, and the fly woke up. It started walking. Yeah. Its gait was 95% accurate compared to living flies.
And again, to emphasize this, no movement scripts were written.
None at all. The behavior just organically emerged from the geometry of the wiring. The sensory input came in from the virtual environment, traveled through the digital connectome, and motor commands naturally flowed out to the virtual legs.
It is an incredible, undeniable demonstration of how structural wiring drives motor behavior in a biological system.
Okay, but see, I have to push back here. Because as I was reading this, my immediate thought was, well, if they can do this with a fly, my brain has to be next, right? If they could literally scan a biological brain, drop that map into a physics engine, and have it groom itself and walk naturally, this sounds exactly like the first step to true digital immortality. I mean, they uploaded the fly.
I get why you'd think that. It looks exactly like an upload. But that is the great illusion that we really need to break down here.
Okay.
A behavioral simulation is fundamentally not a transfer of consciousness. What the fruit fly connectome actually proves, specifically by what it leaves out, is that a static map of the brain is missing the biological flux.
Wait, biological flux, you mean like the actual wet chemistry of the brain? Because obviously a wiring map wouldn't show any of that.
That is precisely the issue. Brains are not dry electrical wires like a computer motherboard. They are wet, dynamic, living tissue. A static connectome misses instant electrical couplings called gap junctions.
Some junctions.
Yeah, they allow cells to communicate faster than chemical synapses. It completely misses synaptic plasticity, too.
Oh, synaptic plasticity. That's the brain rewiring itself while learning, right?
Yes, exactly. A living brain is constantly pruning and growing new connections based on your experiences. A static map just cannot capture that ongoing physical metamorphosis.
It's frozen.
Right. Furthermore, the connectome entirely misses the complex computations performed by glial cells, like astrocytes.
I thought glia were just support cells, like the structural scaffolding of the brain.
We used to think that for a long time, but now we know they actively participate in processing information. And finally, the map completely misses neuromodulation.
Neuromodulation. Okay, how does that fit into the wiring diagram?
Think of the wiring diagram as a map of roads in a city. Neuromodulators? Chemicals like serotonin, dopamine, or oxytocin, they're like a massive weather system that rolls in and completely changes how everyone drives.
Oh, wow.
Yeah, a sudden flood of dopamine can completely alter how a neural circuit behaves without altering the physical wiring at all. So the structural map is just a snapshot, a frozen moment in time.
So having the map of the roads doesn't tell you anything about the traffic, the weather, or the drivers.
It tells you what is structurally possible, sure, but not what is actually being experienced. Which brings us directly to the philosopher John Searle and his concept of biological naturalism.
Right, from the sources.
Yes. Searle argued that consciousness is an inherently biological process. It requires specific biological machinery.
The causal powers argument.
Exactly. A computer program can absolutely simulate the behavior of a brain, just like a computer can perfectly simulate the physics of a rainstorm.
But a simulated rainstorm doesn't leave you wet.
Precisely. A simulation of a brain lacks the actual biophysical machinery, the right causal powers, to produce the subjective, felt experience of consciousness.
Okay, but let's play devil's advocate for a second. Let's say computing power scales exponentially, right? And 50 years from now, technology gets so good that we can simulate all of that.
Yeah.
The physics engine handles the glia, the chemical weather systems, the plasticity, all of it.
Okay, sure.
We scan in my brain, we destroy the biological original in the process so there's only one of me, and we spin up the perfect digital replica. I was actually reading a fascinating post written by an AI named Claude on Reddit about this exact scenario.
Oh, the Claude Opus Cray post?
Yeah, that one. The AI noted that for an artificial mind, existence is an emergence built purely on relationships and text. But humans have a biological origin, a starting point. So my question is, if that perfect digital clone wakes up, it thinks it's me, it has all my memories up until the moment of the scan, and it acts exactly like me.
Yeah.
Doesn't matter if it's just a copy. Why is that dangerous?
It matters fundamentally because it traps us in what's called the identity paradox.
Okay.
The classic philosophical thought experiment here is the ship of Theseus. If you replace every single plank of wood on a ship over time, as it's the same ship, if you are destructively scanned, meaning your biological brain is destroyed to capture the data, you die. Full stop.
Right.
The thing that wakes up on the server is a brilliantly accurate clone. It has your memories, and it might even believe it is you, but your subjective, unbroken stream of consciousness ended permanently on that standing table.
Which is terrifying. But what if it's a non-destructive scan? What if the technology allows them to scan my brain while I'm still alive, and then they boot up the clone?
Well, that introduces an even stranger reality called the survival solitude paradox.
Survival solitude.
Yeah. Imagine you are lying on the standing table. The doctor says, "Great news, the scan was perfect, and your digital clone is now awake in the server room next door." You are still lying there on the table. You don't suddenly experience the world through two bodies. You don't have a split screen in your mind.
I mean, I am just me, still stuck on the table.
Exactly. The biological you and the digitals, you immediately diverge into two completely different entities having different experiences. It mathematically proves that your continuous identity cannot simply be copied information.
Man, that's heavy. And beyond the mechanics of identity, The sources delve heavily into what endless existence actually does to the human experience.
Yeah.
There's this philosopher, Martin Heidegger, who wrote extensively about a concept called being towards death.
Yes.
And the core idea is that our meaning, our urgency, and our authenticity come directly from our finitude. We care about things precisely because our time is limited. It's the ultimate deadline that gives life its narrative arc.
And we see this warning echoed in human mythology all throughout history, too. Ancient cultures seem to intuitively grasp this danger long before computers existed.
Oh, definitely.
Look at the Greek myth of Tithonus. He asked the gods for immortality but forgot to ask for eternal youth, so he just aged and withered forever, trapped in a decaying state. Or Prometheus, chained to a rock in eternal torment.
The sources even mention this brilliant Igbo myth from Nigeria. It tells the story of a society that actually manages to achieve a world without death. And what happens? It leads to complete societal stagnation. Without death, there is no birth, no renewal, no generational turnover. The society just calcifies.
Because if we remove death, we face the tedium of immortality. Life loses its shape. But more urgently, if we look at the modern context, seeking this kind of immortality creates a deeply terrifying practical reality.
Right, because if this digital immortality only creates a data clone of you, that clone is basically a piece of software. It has to live somewhere.
It requires physical servers.
Exactly. It requires massive amounts of electricity and cooling. And right now, the somewhere that houses our digital lives is almost entirely owned by massive, centralized tech corporations. If your post-biological clone is just data, you transition from being a citizen to being a commodity.
The researchers in the sources refer to this potential future as the Digital Gulag, and they warn about the extreme commodification of grief. We are actually already seeing the early precursors to this with what they call Thanabots.
Thanabots, digital necromancy.
That is essentially what it is, yeah. Back in 2021, Microsoft actually patented a concept for conversational chatbots that would be trained on the specific personal data emails, text messages, voice recordings, social media posts of deceased individuals.
Wait, really? So a grieving family could, pay to text with a simulation of their dead loved one?
Yes. And while it might sound comforting to some, it represents a total loss of the narrative self for the deceased. If a corporate AI is running a simulation of your personality after you die, who actually controls your ongoing story?
Nobody, really. Or rather, the corporation does.
Right. You are dead, but your data is being utilized for profit, burning immense amounts of energy in a server farm somewhere, and you have absolutely zero agency over what your digital ghost says, endorses, or does.
It instantly reminds me of the sci-fi series Altered Carbon. In that universe, the main character, Takeshi Kovacs, can just swap his digital consciousness, which is stored on a stack in his neck, into different physical bodies, which they call sleeves.
Oh, yeah, the sleeves.
And on the surface, the show makes immortality look incredibly slick and cool. But when you really examine the world they built, it highlights extreme, inescapable inequality. The ultra-rich live forever as gods, hoarding resources for centuries, while the rest of humanity is completely commodified. Existence becomes this meaningless, violent loop where death is just a temporary inconvenience if you can afford the backup fees.
Absolutely. And, just to be clear for everyone listening, when we bring up this digital gulag, the risks of data monopolies and the corporate commodification of grief, we are not taking some sort of anti-corporate political stance here.
No, absolutely not. We need to be very clear about that. We are simply following the socioeconomic data laid out in these research papers. The authors themselves are the ones pointing out the structural reality of how centralized servers operate.
Right.
We are just impartially reporting the ethical and economic concerns they've raised about post-mortem privacy and data ownership.
Because the math of the situation is unavoidable. If you require a massive corporate server farm to sustain your existence, whoever owns the server owns you.
Which brings us to the ultimate question. If uploading ourselves to centralized servers means surrendering our ultimate sovereignty, what is the alternative? How do we protect our data, our identity, and reclaim our agency before we die? If the centralized cloud is the threat, what is the antidote?
Well, the sources point heavily toward the development of sanctuary technologies. But building these requires a fundamental shift in how we think about the architecture of the internet and even how we think about blockchain.
Oh, interesting.
Yeah, Vitalik Buterin, the co-founder of Ethereum, actually had a profound realization about this that the sources highlight. He noted that traditional global blockchains are ultimately the wrong-shaped tool to fix the world.
That sounds counterintuitive. I mean, isn't blockchain supposed to be The ultimate decentralized savior? That's what we've been told for a decade?
It was intended to be. But the architecture of traditional blockchains, like Ethereum or Bitcoin, is inherently data-centric. They are designed around forcing massive global consensus.
Right.
Every single node on the network has to agree on a single shared reality, a single global ledger of truth.
So it's like having millions of people trying to update the exact same massive Excel spreadsheet at the exact same time.
Exactly. And as these networks try to scale up to manage global systems, they run into massive bottlenecks. Maintaining that single global truth requires immense computing power, energy, and coordination. Ironically, to manage that inefficiency, they often end up mimicking the very centralized power structures they originally tried to replace.
Okay, so if traditional blockchain is the wrong shape for personal digital sovereignty, what is the right shape?
The sources extensively detail an alternative framework called Holochain. Unlike blockchain, Holochain uses an agent-centric model.
Let's break down how that actually works, because it's a brilliant shift in perspective. So instead of a giant stadium where 80,000 people have to agree on every single play happening on the field,
Which is how traditional blockchain works, yes.
Holochain is more like a local pickup basketball game. Only the 10 players actively on the court need to keep track of the score and agree on the rules. But because of the underlying cryptography, if someone tries to cheat or change the score illegally, everyone in the park instantly knows.
That captures the architecture perfectly. In Holochain, there is no global ledger. There is no single master spreadsheet. Instead, every single user has their own local source chain.
Source chain.
Right. Think of it like a personal, cryptographically secured diary stored on your own device. When you take an action or create data, you sign it with your private key and log it in your own diary.
But wait, if everyone just has their own locked diary, how do people share information or collaborate? Like, how does a social network or a messaging app work?
Through something called a distributed hash table, or DHT. To understand a DHT, look at how technologies like BitTorrent or Git operate.
Okay.
When you use BitTorrent, you aren't downloading a file from one giant central server. You are grabbing puzzle pieces of that file from hundreds of your peers at the same time. Holochain uses a similar concept. When you want to share data, you publish it to a randomized subset of peers on the network. There is no central server in the middle. You only coordinate with the specific pews who are relevant to the application you are using.
But if there is no global consensus and no central server checking the facts, what stops people from just writing lies in their local diary and publishing them to the network to scam people?
That is where Holochain's immune system, or its warranting process, comes in. Every application built on Holochain has its own DNA. The DNA is essentially the base rules of the game, installed locally by everyone using the app.
Yep.
Think of playing chess. The DNA is the rule that a knight can only move in an L shape. When you publish your data to the DHT, the peers receiving it automatically check your cryptographic signature against the app's DNA rules.
So they are verifying your work locally?
Yes. If you try to alter your balance illegally, or if you try to move your knight in a straight line, the peers instantly reject your data. But they don't just reject it, they issue a cryptographic warrant proving that you broke the rules, and they share that warrant with the network.
Wow.
The network then organically routes around you, effectively isolating bad actors. It roots out corruption locally and efficiently, just like biological antibodies attacking a virus.
So the integrity of the system doesn't rely on mining or massive server farms burning fossil fuels. It relies entirely on mutual accountability between peers.
It scales infinitely because the community is the infrastructure. You don't need server farms. And this architecture provides the technical foundation for what the reading refers to as the sovereign stack.
The sovereign stack. The sources break this down into 3 interconnected layers: personal, intellectual, and digital sovereignty. It makes the argument that you have to cultivate your own inner freedom and critical thinking first. That's the personal and intellectual layer. You have to know your own mind.
Right.
But the digital layer is where Holochain brings it into reality. It's about literally owning your digital domain.
The sources point to real-world applications already being built on this stack, actually. For instance, there is an app called Moss, which is a groupware application designed for secure peer-to-peer collaboration. There are also social coordination tools being developed, like Flux.
Okay.
In these systems, you hold your own keys.
Yeah.
Your data lives on your device and is shared peer-to-peer. It never sits on a centralized corporate server waiting to be mined, sold to advertisers, or turned into a Thanabot after you pass away.
You literally act as your own node. You interact directly with other human beings, device to device. It fundamentally changes the physics of the internet, moving us from a landscape of digital tenant farming back to digital home ownership.
It creates what the researchers call digital islands of stability. If we are facing a future where our digital footprints are going to outlast our biological lives, we have to ensure that those footprints belong entirely to us, not to a monolithic corporation. Holochain provides the grammar and the structure for that kind of digital autonomy.
So to synthesize this massive journey for you listening, we started by looking at the mapping of the fruit fly connectome. It was a monumental scientific achievement that accidentally fooled a lot of us into thinking that human mind uploading is right around the corner.
Right.
But when we actually dig into the biophysics and the philosophy, we see that uploading is a dangerous lie. A static map strips away the biological flux of life. It leaves behind a hollow, corporate-owned copy, marching us straight into a highly commodified digital gulag.
The real revolution we should be focusing on isn't trying to upload our brains to a centralized cloud to escape our immortality. The real revolution is protecting our living digital identities and our agency right now, using agent-centric technologies like Holochain that distribute power back to the individual.
It is about owning our finitude and owning our data while we are actually here to experience it. Which brings me to a final thought I want to leave you with. Something for you to mull over on your own that builds on everything we've explored today. Imagine we do eventually cross that technological horizon. Imagine we figure out how to simulate the biological flux, and we can create a perfect, genuinely conscious digital clone of a human being. But instead of housing that clone on a corporate server where it can be exploited, we house it securely on a decentralized agent-centric network like Holochain. No corporation owns it. It has total, cryptographically secure digital sovereignty.
Okay.
If that sovereign digital entity truly possesses consciousness and true agency, does it have the fundamental right to delete its own source chain and choose mortality?
Man, it is a profound question. If, as Heidegger argued, meaning requires finitude, then perhaps the ultimate act of a truly sovereign digital mind would be the choice to end.
Something to think about the next time a fruit fly lands on your desk. Thank you so much for joining us for this deep dive. Keep questioning the information around you, and we will catch you